Okay, 4-3, we're going back to chapter 4. We're flip-flopping again, and we're going to talk specifically about congruent triangles today. And we're going to use properties of congruent triangles, and then in class on Monday, we're going to prove triangles congruent by using definition of congruency. And we'll do this in class. So that means get excited for proofs. So since we're talking about congruent triangles, let's first start off with what does congruent mean. Congruent figures, congruency, means same size and same shape. So congruent figures have the same size and the same shape. That means that their corresponding angles and their corresponding sides are in the same position and are also congruent. So to sum it all up, two polygons, so two shapes, are congruent if and only if corresponding sides are congruent. So since we have that if and only if, since we have that biconditional statement, that means it works forward and backwards. So if I read it this way, two polygons are congruent if, or if two polygons are congruent, then their corresponding sides are congruent, as well as the converse of that works. So if we have corresponding sides that are congruent, then that means that those things are going to be congruent. So it works both ways. Either way you read it, it's going to be a true statement because of this if and only if. Okay, so since we're talking specifically about triangles, triangles that have the same size and have the same shape are going to be congruent triangles. And so what I want you to focus on is the corresponding angles and the corresponding sides, because that's going to be important for later on in the chapter. So let's say I give you these two triangles, and I'll call them triangle ABC. And then this other triangle doesn't look the same, but I'm going to tell you that triangle ABC is going to be congruent to triangle DEF. This is called a congruency statement, and we'll talk about why this is an important statement. If I took this figure, this triangle, it kind of doesn't look like they're congruent, but if I rotated it around, you can see, if I put it on top, you can see that these are exactly congruent triangles. Okay. So it'll be easier for us to talk about corresponding angles and corresponding sides now that they are in the same position. So corresponding angles are in the same spot, same position. So A and D are going to be corresponding. B and E are in the same spot, so they are corresponding. And C and F. We can also have corresponding sides. Corresponding sides are the same thing. They're sides that are in the same position. So A, B, and D, E are corresponding. B, C, and E, F. Oops. And then A, C, and D, F. So it's important that you know corresponding means that they're in the same position. Now, since I told you that these two triangles are congruent, that means that their corresponding angles and their corresponding sides are going to be congruent to each other. So I can replace these and signs with congruent signs. Angle A is going to be congruent to angle D. Angle B is going to be congruent to angle E. Angle C is going to be congruent to angle C and F are going to be congruent. So I can put my tick marks on my picture to show that as well. Tick mark, double tick, triple tick, triple tick. All right, so we can look at a picture and we can tell which ones are corresponding sides and angles because they're in the same position. Again, sometimes it might help if you rotate it. Another thing that's pretty cool is you can just look at a congruency statement. Again, this is the congruency statement. And just by the congruency statement, without a picture, you can tell which ones are corresponding and thus congruent. So since I told you they're congruent, that means the corresponding sides and angles are going to be congruent to each other. Now the corresponding, if you look at the original corresponding, if we go back just for a second, if you look at this original congruency statement, if you notice, A and D we said were congruent, and in the statement A and D were in the same position. Same with B and E. Angle B is going to be congruent to angle E because they're in the same position in the congruency statement. C and F are both at last, and they're both congruent to each other. Same thing for the side lengths. DE are the first two, and AB are the first two, so they're going to be congruent sides. So if you don't have the picture, you can just look at the statement, and you can tell which ones are congruent angles and which ones are congruent sides. So since P and S are the first ones, they're going to be congruent to each other. Since Q and R are in the middle, Q and T, and then R and W are last, so they're going to be congruent to each other. Same thing for sides. PQ and ST, QR and TW, and then PR and SW. And again, it's important that we put those signs because we're talking about congruency, so we're talking about things. Okay, so that's one way to do it from pictures and by just looking at the statement. And there should always be 6 things when we're talking about triangles, because there's 3 different sets of angles and 3 different sets of sides. The last thing we're going to do is use those corresponding parts to figure stuff out about congruent triangles. So again, I have to tell you that these triangles are congruent, and then we can actually solve some stuff. So for example, looking at this congruency statement, this is a little bit easier of a picture, but I want you to first look at this congruency statement. A and D are congruent to each other. So since this is 49.3, this one also has to be 49.3 degrees. Since C and C are in the same spot, that means they've got to be congruent to each other. So that means this angle has to equal this angle. So let's say I wanted you to solve for x. Well, since these 2 angles are congruent to each other, both because we have perpendicular lines and because of the congruency statement, you can set them equal to each other and solve. So if I add 16, I have 2x equals 106, and then divide by 2, and I get x equals 53. I think I did that right. Okay. So now I have x equals 53. This angle is still going to be 90 degrees. That's one type of question I could ask you. So you have to use the congruency statement to figure out which ones are equal to each other. The last thing we can solve, since we know this angle is 90 and this angle is 49.3 and this angle is 49.3, the last thing I could ask you is to find the measure of angle DBC. And that's just using properties that we've already learned, the triangle sum theorem. Since all angles add up to be 180 degrees, you can just look at one right triangle and you can subtract 90 and 49.3. Since this angle is already 90 degrees, you wouldn't have to add them up and subtract it from 180. You could just subtract it from 90. So then that would be 50.7 degrees. So this angle would be 50.7. And then since the B's are in the same spot, that means this angle would also have to be 50.7. So you can check your work by looking at this other small triangle as well as looking at the entire big triangle, triangle ABD, to see if all the angles add up to be 180 degrees, which they should. 49.3, 49.3, and then 101.4. So this whole triangle ABD, now that we know we have congruent angles right here, we can also say that these 2 sides have to be congruent because it's an isosceles triangle if you look at this entire triangle. Pretty neat. So you can tell a lot from a triangle just by using corresponding parts of congruent triangles. Tomorrow in class we're going to work on, or the next day in class we're going to work on proofs. Today I want to make sure you guys know how to do this. So you're going to do page 234. You're going to do numbers 6, 7, 9, and 10. And fun fact of the video, did you know at Disneyland, let's see, where is it? Disneyland, the buildings along Main Street, which is that first street that you come into, were built to create the effect of a longer street when you're entering the park, but also a shorter street when you're going back to your car. That's pretty cool. I don't know. I mean, that takes a lot of geometry. I'm not sure how they did that. We'll have to figure that out in class. Okay, so you have your assignment. Have a great week. And Thanksgiving. Yay, happy Thanksgiving.